Hello and welcome. Today we're going to deconstruct a really fascinating piece of 6th grade educational material. It's this wild combination of geometry and ancient history that you just don't see every day. Okay, let's jump right in.
So what on earth connects a vineyard in ancient Israel to 6th grade math? I know, it sounds like the start of a weird joke, right? But that's the central puzzle of this entire lesson. And trust me, by the end of this, you'll see exactly how one simple shape helps make sense of the world, whether we're talking about today or thousands of years ago.
And the key to unlocking this whole thing, the one mathematical tool we're going to be using, is the trapezoid. It's a shape you've probably seen a million times without even thinking about it.
So what is it? Super simple. It's a four-sided figure, but with one special rule. Only one pair of its sides are parallel. Think of a tote bag or maybe a lampshade. That's a trapezoid.
And here it is, the key to the whole operation, the formula for its area. All you do is add the two parallel sides. We call those the bases. Multiply that by the height, and then just chop the result in half. It's a beautifully simple formula, and as we're about to see, it is incredibly powerful.
Okay, so we've got our tool. Now let's actually put it to work. We're about to see how this one little formula can be applied to everything from humble vineyards to grand temples, all taken from the lesson's biblical world.
Let's set the scene for our first problem. Imagine we're in ancient Israel, mapping out a plot of land for a new vineyard. The land isn't a perfect square or rectangle, it's a trapezoid. So how do you figure out the exact area? Well, the source material gives us our numbers. For this vineyard, one base is 8 meters long, the other is 5 meters, and the height between them is 4 meters. Let's plug them into the formula.
Okay, first we add the bases, 8 plus 5, which gives us 13. Then multiply that by the height of 4, and we get 52. And the last step, divide by 2. The area of our vineyard is 26 square meters. See, the formula works like a charm.
Let's keep it moving with our next example. This one takes us to a corner of a barley field, a scene right out of the story of Ruth. It's another totally practical, real-world use for our formula.
So for this barley field, the numbers are different, but the process is exactly the same. Our bases are 7 and 3 meters with a height of 6 meters.
Let's run the calculation a little faster this time. The bases, 7 and 3, add up to 10. Multiply by the height of 6, you get 60, and half of that gives us a final area of 30 square meters. You can see how reliable this is.
And for our final example, we're shifting gears from agriculture to architecture. Now we're measuring a platform in the courtyard of Solomon's temple, which just goes to show how versatile this one formula really is. And for this grand finale, the temple platform, our bases are 10 and 8 meters with a height of 5. Okay, one last time through the formula. 10 plus 8 is 18, times 5 is 90, divided by 2, and we get 45 square meters. And that's the real takeaway here, isn't it? It doesn't matter if it's a vineyard, a field, or a temple, the math, the principle stays the same.
So now that we've seen it demonstrated a few times, the source material kind of moves into a homework phase, a little rapid-fire challenge to make sure the idea has really clicked.
So what do you think? Are you ready? Let's test what we've just learned with 4 quick problems.
Okay, let's just run through these. We've got another vineyard, a tent panel, one with decimals just to keep us on our toes, and a stone slab. All the dimensions and the final answers are right here. For instance, take a look at that tent panel. You add the bases, 11 and 9, to get 20. Multiply by the height of 4 to get 80, and divide by 2, boom, 40 square meters. It's a great way to lock in the concept.
But the lesson doesn't just stop with simple calculations. It moves on to one final creative challenge, which is all about applying what you've learned in a totally new way.
The final task is to create your own word problem using the formula, and it has to involve a Bible character. Honestly, this is a brilliant teaching move. It forces you to not just solve a problem, but to understand all the pieces well enough to build one from scratch. And the source even gives us an example. Queen Esther's hosting a banquet on a platform. The bases are 10 and 6 meters, and the height is 3. We run our formula, and we get a final area of 24 square meters. It's a perfect blend of the theme and the math.
And this brings us to the very end of the lesson, where we kind of shift from the how of the math to the why. What's the deeper point of all this? The source material pairs this whole lesson with a Bible verse of the day. And this one, from Proverbs, really frames the entire exercise. It's all about the value of being careful, of being a diligent planner. And this is where it all clicks into place.
This isn't just about math. It's a moral lesson. By connecting this verse to geometry, the lesson is saying that precision itself is a virtue. The ability to measure, to plan, to be careful, that's the kind of diligence that leads to good things.
Which leaves us with a final question to think about. If something as straightforward as calculating an area can be framed as a form of wisdom, well, what other everyday skills, things like budgeting our money, organizing our time, or even just listening carefully, are we overlooking as powerful virtues in our own lives?